Hello friends, welcome back. So in this session we will learn process, executor, executor service, thread pool executor, scheduled thread pool executor and executors class. So first we will start from process. So what is process? Process, as we have already seen in multi-threading session, we have already seen process is nothing but a system applications only. Process is nothing but an application only, and thread is the part of application. We can say that process is executed at system level and thread is executed at application level. So process class is representing to your system process, any process, like you are opening a VLC player, you are opening Notepad, you are opening Firefox. That is one process only, one process only. So you can, using Java, you can start that process and you can terminate that process. You can get the information of that process, or you can or any other like commands if is required to for that process, you can pass the, or you can handle that process, you can say that one. Whatever the process process functions, like starting a process, closing a process, getting the information of process, or handling the process. So all that functionality you can do using process, but this is an abstract class. We must subclass this one, but that we no need to do. We have to just give the commands, and using that commands we can create the process. So this is the default constructor. Here we have defined some constructor, and this is a description. So there is a one constructor in that process class, that is a process. Get output stream, another method. All the methods are abstract because in the subclass only you have to give the implementation. We have already seen this one. So output stream, what exactly it will return? It will return the output stream that is connected to this process. Output stream is a piped into the standard output of the process represented by the process. Output stream means what? Where you will write the output for that process. For that purpose, output stream is required. So this method will return output stream that is connected to that. We will see what is input stream, what is output stream, then input output. When we will start IO package, input output package, at that time we will see what is output stream, what is input stream, what is print stream, how many types of streams are there, how we can create streams, how we can read streams. All these we will see when this IO package will start. Here only just we have to understand, using this output get output stream, we can get the output stream that is connected to that process, and using input stream we can get the input stream that is connected to that process. Error stream is nothing but input stream only. Okay. wait for case the current thread to wait if necessary until the process represented by this process has been terminated. This method return immediately if the process is already terminated, otherwise it will wait. And we can give wait for some timing. This is wait till that it is not notified. Otherwise wait for, we can use wait for means for this much time. This is the time unit, like that time units. If suppose if we are giving here 1 and time unit we are giving minute, this means wait for 1 minute. Here you can give time unit also. Okay, so by specifying this time we can put into waiting state. Exit value, return the exit value of process. Suppose After exiting, whether there's normal execution or abnormal executions, whatever the value is representing integer number, that is exit value. Destroy is nothing but to kill the process. You have to terminate the process. For that purpose we are using destroy method. Destroy forcibly. Sometimes what happens, we are trying to close some process, but that process is not being closed because of some deadlock or something, it is stuck. You cannot close that one at all. In that case we can use destroy forcibly. It will kill the process forcibly. And supports normal termination. Suppose the termination that is normally happening or abnormally happening, it will returning the flag, that one. Return true if the implementation of destroy is normally terminate the process. Return false if the implementation of a destroy forcibly and immediately terminated the process. Is alive will check whether the thread is in running mode or it's in suspended mode or it is in destroyed, something like that it will tell. PID will return a process ID, means in your operating system each process has a process ID, and that process ID is nothing but a long number long number only. Means inside your operating system, suppose 10 processes are running, so for that 10 processes they have given a unique ID. Your operating system is given a unique ID for each process, so that is called process ID. You can get that process ID. Exit, on exit, if you want to do something, then compatible future java.lang process, it will returning using this one. You can do that process. Okay. And to handle, process handler, it will return process handler. Using this process handler you can get the information about the process and what can be we can handle the process also, and we can get some information like a username, who is the username for that process, at what time it started, and what will be the command for that one, what will be the parameter, and what is the path where exactly this process is residing in your operating system. All this information you can get from this handler. Using info also, that is a info, what exactly info is returning, info, process handler info, it is returning info only. Using process handler you can get info, or from the process directly you can get info. Children, it will return if any sub processes are there. For that processes it will return the handler. Return the snapshot of the direct children of the process. The parent of a direct children process is a processes in the process. Okay. And descendant return the snapshot of a descendants of the process. So let's see one example of that one. Suppose this is one process. So process, how we can create, we have seen that one constructor is there, we have seen already one constructor is there, but we cannot create object for this process because this process class is an abstract class. Process class is an abstract class, so we cannot create object. Then how we can create process? We can create process using process builder. New process builder. Here you can give your operating system command, because in your operating system some command, whether it is your Linux operating system or whether it is a Windows operating system or Mac operating system, in the terminal or in command line you are typing some command and you are pressing enter. After typing that command, one process is executed, so that process you can specify directly here. So this is the Firefox. I am trying to opening Firefox. So this is the one process, and then I started this process. After starting this process I waited for 20 seconds, or I can increase this time, no issue. This is for 1 minute. I waited for 1 minute, or 30 seconds I waited. After waiting 30 seconds, I am just trying to destroy this process. I am terminating this process. So in this way we can create, or else we can create process using runtime, that we have already seen. This one. Runtime is a one singleton class in your Java. Using get runtime, you can get the runtime object. From that runtime object, you can execute any, this is execute any command, execute any process, and this method will return a process object. So in this way we can do, or in this way we can do, no issue, however you want to do. So let's run this one and see the output. So it will start. Yes, it's started. Okay, let's just I'm opening Wikipedia. Okay, internet is not there, so fine, no issue. So so if we see I am not closing this one. After 30 seconds automatically it is closing, because I am waiting for 30 seconds. After starting this process, I am waiting for 30 seconds. After 30 seconds, I am closing the process. So see, automatically it's closed now, because we are handling. I will run once again and I will show you again. This time I will not do any interaction with this one. Okay. Suppose just we have opened this one and I am just kept as it is. And you will see after 30 seconds, after starting this one, after 30 seconds this application will automatically closed. This is a process, that process we are closing, it will be closed. Yes, see, it's automatically closed because we are waiting for 30 seconds. After 30 seconds I am just closing it. That's it. Okay, so this is about the process class. Next one is executor, executor service, thread pool executor, or scheduled thread pool executor. What exactly it is? This is the classes, or some of them are abstract class, or some of them are abstract class, or sorry, some of them is an interface, or some of them are concrete class. What exactly the use of them? That is used to execute the threads, that is used to execute the threads at some specific time, or scheduled time, or after some interval time, regularly, like that. We have already seen how we can create threads, how we can run threads, what are the methods of thread, that we have already seen. So here we will see how we can execute the threads, and these classes are used to execute the thread. First one is executor. Executor is nothing but, see, okay, this is the diagram, this is the API hierarchy, or you can say class hierarchy for executor, executor service, abstract executor service, scheduled executor service, or scheduled thread pool executor, or thread pool executor. This is the, so how we can see, this is whatever the circle you are seeing, that is representing interface, and this box is representing, or this square is representing to a class. This is representing to class, and this circle is representing to interface. So this is an interface. From this one you can understand executor is nothing but an interface, and executor is available in the java.util.concurrent.executor, and this is also available in java.util.concurrent.executor service, that is executor service, that is also an interface, and java.util.concurrent.scheduled executor service, that is also a interface. Abstract class java.util.concurrent.abstract executor service, that is a class, and that class is inheriting executor service. And scheduled executor service is an interface that is inheriting executor service, and executor service is an interface that is inheriting executor. And ThreadPoolExecutor is a concrete class that is inheriting abstract executor service. And scheduled thread executor is another concrete class that is inheriting both, that is inheriting scheduled executor service and ThreadPoolExecutor. Both scheduled executor service and ThreadPoolExecutor, both it is inheriting, that is scheduled ThreadPoolExecutor. So first we will see this executor. Suppose, what is executor? Let's go to thread. My executor. Okay, so here I have given my executor. What I did, I have inherited java.util.concurrent.executor. If you open that executor, this first one executor, so this executor is an interface from Java 1.5, and that has only one method, that is execute, and it is taking a runnable. We have already seen this is runnable. Runnable is an interface that is used to create the thread. Okay, so in this executor only one method is there, that is execute, and that is accepting or runnable type object. That's it. So what I did, I implemented that in my executor. This is my class, my executor. Here I am giving fully qualified class name, or else you can give in this way also, no issue. Import dot executor, not executors, executor. That's it. Implement executor. That's it. You can give in this way, no issue. That is up to your choice. You want to give fully qualified class name, that also you can give. You can use here that one. That's it. That is up to your choice. You can use. See, that is also fine. In that case, when that is useless, you don't need to do this one. That is up to your choice. You want to use class as a fully qualified class in class name, you can use that one also. Okay, so this is executor. Inside that one method is there, execute, that we have overridden. So I have overridden that one, a runnable command. This is nothing but that runnable type reference only, and on top of that one I am creating new thread and I'm just applying dot start. That's it. So my executor I can use to execute any thread now. So if I open executor main, and what I am doing here, this is my executor. So using this my executor, what I am doing, first my executor I created using this my executor, a thread A. We have already seen this example, thread A, that is a thread that is implementing runnable interface only. That's it. So using this one only I have created a thread. That thread I have passed into this one, and remainings I will comment once. That is different. Okay, yes. So what will happen if you run this one, you will see the thread is executed now. See, this is a thread 1, I think thread A. Thread B, you want to do thread B is also there now. Any thread you can execute. Thread C is also there, or multiple threads also you can execute, no issue. 3 threads are there, no? You want to execute all, you can use that one, you can execute that also. thread B, sorry, and thread C. Now all the threads will be executed. All the threads will be executed one by one. See, that is not guaranteed that this thread will be running fast or this thread will be running later only. Sometime it will be different. Okay. So this is a one way. This is a one way to execute the threads, but that is our implementation only. That is our implementation only. No. What we can use, we no need to give any implementation in this way. Suppose another one is executor service. This one. That also we can give implementation, but we don't need to give implementation, because what is the executor? If you see that last one, this executor is providing all these features. From the executor you can get any type of object. You can get executor service, you can get scheduled executor service, you can get ThreadPool executor, or you can get scheduled ThreadPool executors. Whatever you want to get, you can get. You no need to do any you no need to give any implementation for that one. You no need to give that one. So here what we are doing, you can observe here. See, this executor is a class. That executor is a class with private constructor. What is the use of this private constructor? You cannot instantiate this class, means you cannot create object for executor, because all the methods are static. You will see static. This is different. Go. See, static, public static. All the methods are static. If all the methods are static, then directly you can call that class name. That only we are doing. Executor.new catched thread pool. This is a new catched thread pool. It is returning executor service only. It is returning this object executor service, because this is currently this executor service is an interface. We cannot create the object. To create the object, we have to give the implementation, but we no need to give that implementation. That implementation is already provided into this executor, new cached executor. This new cached executor, it is creating here. You see, ThreadPoolExecutor. Which one? ThreadPoolExecutor. Yes, this one. ThreadPoolExecutor. We are using executors dot, what we are applying, executors dot, if you see executors dot new catched thread pool executor, and this catched thread pool executor is returning executor service. Executor service is nothing but thread pool executor only, and this thread pool executor you have already seen. This is a concrete class, so we can create this object, no issue. If you want, but you no need to type that new or something like that. Directly with this method you can directly use that one. That's it. It is a simplified way. So executor service, using this executor service, I can typecast that into thread pool executors. Why? Because this, on this class, when we are calling, it is returning executor service, but executor service is nothing but thread pool executor only. So that one we can typecast into thread pool executor, no issue. Thread pool executor. Using this thread pool executor, first I am applying what exactly the size, then I am adding 3 threads I am adding, then I am printing features, then I am printing how many threads are there, then I am shutting down this one. So this is the executor service. Suppose from this executor service we are getting thread pool executor. Using this thread pool executor, first I am taking, this is my pool, this my pool reference, thread pool executor reference variable is my pool. Get pool size. What exactly the pool size now currently, because pool size will be 0, because currently there is no thread, but after that one I have submitted one thread here, another thread I have submitted here, and this is also a thread only. It is also thread only. See, this is a callable thread. See, callable also is a thread only. See, if you see the callable, what exactly the use of this one? Callable has a one method, that is a call. Callable has a one method, that is a callable, and this callable, what exactly the advantage we are getting here? Because if we see sorry, if we open Runnable, inside this Runnable, run method is there. That run method don't have a return type at all, and that return type is also not there, and that is, if it is return type is there, then that is not generic also. But in callable, one extra feature is there, that we can specify here the type also, what exactly the type should be, because this is a generic. This is a generic. We will learn what is generic actually. Currently you understood this call method has a return type that can return any types. Any types mean we can specify what types I want to return, that you can specify here. Whatever type you will specify, it will return that type. So this is the use of this callable. Using this callable also you can create threads. So how we can create the callable thread using this callable? See, in this way. I have implemented my callable. I have created my callable class and implemented callable. Here I have specified the string. Callable thread should return string type object. So in this method, it automatically taking string type only, and in this string type I am returning hello world, and I am printing my callable running, and I have created my runnable also, and that is printing my runnable running. That's it, my runnable running, my runnable running, my callable running. Okay, yeah, that's it. So what I did here, I have not submitted here any callable. If you want to submit callable, you can submit, no issue. How can you submit callable also? My callable, sorry, not my callable, my my runnable, sorry, callable we are submitting here. Callable also you can submit, no issue. You can give this one, no issue. See, yes, that is up to your choice. You can give callable, you can give runnable, you can give thread, you can give any. So this will execute, this will execute, this will execute, and this will execute, and this is returning a future. Future means after it will return something that is coming in future, and from the future we can getting the result. So it will return what exactly this will return? This will return this value, hello world, hello world. And then I'm printing here total thread scheduled pool. How many totals are there? 1, 2, 3, 4. And what will be the pool size? 4. Okay. And now after that one I'm shutting down. Yes, executed. Total number of threads scheduled 4. Thread size of the pool 3. How? Because size will be calculated from 0 to 3. 0, 1, 2, 3. 4 threads are there. 1, 2, 3, 4. 4 threads are there. So the total number of threads scheduled are 4, but size is 3 because it will start from 0. Okay. Okay, then now we are shutting down. So in this way we can create executor service or ThreadPoolExecutor. Executor service or ThreadPoolExecutor. This is an abstract class. We cannot create object. This class is implementing this only, and this is again scheduled executor service. That is also an interface only. So we will use scheduled ThreadPoolExecutor. So this will come. Okay. So the next one is scheduled ThreadPoolExecutor. Sorry, what is that? Why this one? Okay. Okay, something is missing, some braces or some. Okay, Okay, so now what we are doing here, scheduled executor service, new single thread scheduled executor, and this is okay, sorry, that is another one. So this is scheduled executor service only, and this is also scheduled executor threadpool executor, scheduled executor service. Yeah, scheduled executor service is also there. Scheduled executor service. So scheduled executor service we can get from here. This is scheduled executor service, delegated scheduled executor service, new delegated scheduled threadpool executor only, scheduled threadpool executor only, internally that is scheduled threadpool executor only, this one only, scheduled threadpool executor only. But you can assign, because this is a it is returning subtype, you can assign to super type, no issue. Okay, so here in this scheduled executor service, because this is, you see, this is an interface only, but you can apply, because this is a class, subtype class, it is a subtype class only, subtype class, what type of object, this one only, scheduled threadpool executor only. Okay, so here scheduled at fixed rate, we are applying scheduled at fixed rate. I am closing this one. So what exactly it will be? So this is not required. So what it will do, scheduled at fixed rate means after 1 second, this thread will be executed, and after first time, because first time execution of this thread will be happening once after 1 second, after executing once, after 5 seconds each, okay, after every 5 seconds this thread will be executed. This is in milliseconds means, or you can give it, this is in seconds, no issue. If you give in the seconds, then this is huge, 5 seconds, this is a 1 seconds only. That is up to your choice, what exactly. This is the unit, time unit only. What should be the unit? Unit should be minute, hour. If I will give here or no hours, then it will be 5 hours, means first execution will happen after 1 hour, then after each 5 hours this thread will execute, after every 5 hour, that is up to your choice how you want to give. I will give here seconds only, or I will give here seconds only. So after 1 second this will be executed, and after 5 seconds that thread again it will be executing. So let's run and see 1 second, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. So it will be continue like that. After 5 seconds the thread will be executing. So this is the use of scheduled executor service. It will schedule at what time it should execute, at what time of interval it should execute. This is like that only. Okay, and in the same way, this is here we are giving a runnable type, and we can give here callable type also. We have already checked this callable. This is callable. Here we are giving milliseconds, that is again 5 seconds only, so it will call after 5 seconds. But schedule, this is only one time it will execute, not every 5 seconds. Yes, so only one time it is executed, but program is still running. Why? Because we have to shut down this. We have to shut down this first. If we are not shutting down, it will not shut down. It will be keeping like that only, but this will not execute. Thread is not executing, but it will be shut down mode. Okay, yes, shut down. And if you give here like 3 seconds time, then it is not there, huh? That method is not there. Okay, callable, I think you can not call in that way. Let's see, schedule. Okay, yeah, for callable only this delay, this much delay, only one time you can call, but for runnable you can schedule, because runnable is a thread, you can schedule that one. Okay, so this one is scheduled executor, and then last one is scheduled thread pool executor. So this is again thread. After 2 seconds it will call, only once it will call, and we are shutting down here. Yes, we have to shut down also. Okay, so after 2 seconds it is running and it's shutting down. That's it, because 2 seconds only. After that one, I think you can give a 3 seconds. After 3 seconds that's not there. Okay, so this is the thread pool executor. Let me see another SC. Runnable delay. Yes, here runnable delay, initial delay, and yeah, this one is there. This one we can run. So first initial it should be 2 seconds, second initial it should be 4 seconds, and time unit is in seconds only. You can use in this way also, no issue. So it will keep going. After 2 seconds it will coming again, it will come. But we should not shut down in that case. If we shut down, then it will not come. Yes, it will be going on. Because if we shut down, then it will not work. We should not shut down it. Okay, so in this way we can use this scheduled thread pool executor, and you can okay, this is okay, the same thing only, no, it is same only. And next one is this is callable. This is calling to callables only. Callable you can also give. This is callable, and this callable will this callable is returning this scheduled future of a string type, because this callable is a string type only. My callable is a string type only, so it is returning that type only. And if you run this one, you will see what the time schedule we give, 2 seconds or 3 seconds. Yes, scheduled future value, that's it, this one only. Hello world. So this is all about the executor service, thread pool executor, scheduled thread pool executor, and executors that is used to execute the thread or callable. Okay, so so in this one, these many classes actually for this session. One more thing, in the last session, , 2  3  4 5 6  7  8  9  10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 150 151 152 153 154 155 156 157 1 of multi-threading. Last session was, oh sorry, exception handling, not multi-threading. Our last session was exception and exception handling. So in that exception and exception handling, we missed one point. We missed. What? Exception in inheritance relationship. What exactly it is? Suppose I am opening one class and I will show you. Exception. Yeah, exception custom. Okay, so here I have one class A, and another class B. So if you see, class A has a one method 1, and class B has and class B is inheriting class A. Class A has only one method 1, and class B is inheriting class A, and in that case we have overriding that method here. We can override, no? Since this class A, that method is not an abstract method or nothing like that, so in that case also you can override, and we are overriding. But what if this method is throwing some exception? Then what is the possibility? What is the possible cases that whether you can give that throw statement, or you cannot give throw statement? What is the possibilities of that one? So that we missed in the last point. So suppose if super level class method is not specified with any exception. Suppose in our class A, this method is not specified with any method level exception. There is no method level exception. In that case, what your subclass can do, subclass method, sublevel class method may not throw any exception, or may throw exception, no issue. Or sublevel class method can throw any unchecked exception in that case, any unchecked exception. And if the sublevel class cannot throw any checked exception in that case, means if the super level class method is not specified with any exception, then sublevel class method may not throw any exception, or may throw exception. If it can throw, then what type of exception it can throw? It can throw any unchecked exception. It cannot throw any checked exception, or it cannot throw throwable directly, because directly this throwable will be considered as the super type of fault. So you cannot throw like that. So let's see that one. Suppose what I did here, I have defined some exceptions classes. I will show you that first. My checked exception, I have defined one class. My checked exception is a checked exception. From the name it is clear. My checked exception A. This is checked exception. I am extending exception, so that's why it is a checked exception. Okay. My checked exception B. Yeah, this is also again checked exception, but this exception is inheriting exception A. Checked exception A. My checked exception B is the checked exception that is inheriting my checked exception A. Okay, and A is a checked exception, we have already seen. And C is also there, that is another checked exception that is inheriting my checked exception B. And my checked exception is a checked exception that is inheriting checked exception A. Okay, and my checked exception T, that is another checked exception, but it is not inheriting A, B or C. My checked exception T, that is a checked exception, but it is not inheriting A, B or C. But my checked exception A is inherited into B, and my checked exception B is inherited into C, or we can say my checked exception C inheriting B, and my checked exception B inheriting A. Okay, and T is a checked exception, but it is not inheriting A, B or C. It is inheriting it is inheriting exception only, but it is checked exception. Okay, and in the same way, my unchecked exception A I have defined it. My unchecked exception A, that is a runtime exception, means it's a checked exception. Okay. Oh, sorry, it's a unchecked exception. It's an unchecked exception because it is a runtime. We are extending runtime exception. No, in that case, my unchecked exception A is a unchecked exception because we are inheriting runtime class. So this is unchecked exception. And my unchecked exception B, that is also an unchecked exception, but this is inheriting unchecked exception A, my unchecked exception A. Okay, and last one is my unchecked exception T, that is another unchecked exception, means runtime exception only, but it is not inheriting unchecked exception A or unchecked exception B, any of them it is not inheriting, but it is an unchecked exception only. Okay, so this is the exception hierarchy. I hope you understood this one. So what I will do here, we will try to prove these points. Suppose in the first point, what exactly it is saying? It is saying if super level class method is not specified with any exception, then your sub level method may not throw any exception, because if you are not throwing, suppose in the class A, this is a super level class method only, no, super level class method, it is not throwing any exception. So in that case you cannot throw any exception, that is also fine. If you want to throw, then you can throw, no issue. But which one you can throw? You can throw runtime exception, runtime exception, runtime exception, no issue. You can throw, no issue. It is throwing. May not throw any exception. Yes, may not throw. I am not throwing now. Now I am not throwing. I am not getting any exception. I can throw. Yes, sorry. I can throw. Oh, sorry. Throws. Runtime exception. Yes, I can throw, no issue. Or I can throw here runtime. Oh, sorry. My unchecked exception A, you can throw, no issue. You can throw. B, you can throw. C is not there. T, you can throw. Means you can throw or you cannot throw. It is saying you may throw or you may not throw, or you can throw any unchecked exception. You can throw any unchecked exception. You cannot throw checked exception. We cannot throw checked exception. This is checked exception. No, this is checked exception. You cannot throw. Or you cannot throw my checked exception A. You cannot throw. If you see this error, what it will say? Exception, my checked exception A is not compatible with the throws clause in A dot method 1. It's not compatible with that one. Means you can say if your super level class method not specified with any exception, then you can throw exception or you cannot throw exception. If you can throw exception, then you can throw only unchecked exception. You cannot throw checked exception, or you cannot throwable also, because throwable is a super type of that one. That's also you cannot do. You cannot do that also. Okay, so I hope this is clear. This is clear. If super level class method is not specified with any exception, then you can throw exception or you cannot throw exception, and you can throw only unchecked exception. You cannot throw checked exception, or you cannot throw throwable also. Suppose if your super level class is specified with unchecked exception, suppose in the super level class I have specified an unchecked exception, suppose throws, throws my unchecked exception A, I specified here. So what can I do, because this is unchecked exception? Suppose if super level class method is specified with any unchecked exception, then subclass, in subclass method, sublevel class method can ignore the method level exception. We can ignore. Suppose in the class A method level exception is there, but that is unchecked exception. So if it is an unchecked exception, then you can ignore that one, no issue. Or you can throw the same type of exception. Yeah, I can throw same type of exception. Suppose what is same type only? This one only. I can throw same type exception, no issue. Okay. Or I can throw any other unchecked exception. I can throw any other unchecked exception. Unchecked exception means my checked exception B. My that also I can throw. Or T, that also I can throw. Or runtime exception, that also I can throw, because it is saying if super level class method is specified with any unchecked exception, then subclass method can ignore that one, or it can throw same type, or it can throw any other unchecked exception, but you cannot throw checked exception. You cannot throw checked exception. So this is checked exception, this is checked exception, we cannot throw. Or this is also checked exception, my checked exception A, that is also checked exception, we cannot throw. Okay. And the last one is if the super level class method is specified with checked exception, suppose remove this one. So in the super level class, if I specify my checked exception B, anything, this is checked exception only, no? This is checked exception. Third point we are taking, checked exception. If super level class method is specified with any checked exception, then sub level class method can ignore the method level exception. You can ignore, no issue. That also you can ignore. I'm ignoring here. You can ignore, no issue. Means if super level class method is specified with any checked exception, then sub level class method can ignore the method level exception, or it can throw the same type exception. This is same, no? So the same I can throw, no issue. I can throw same type of exception, no issue. Okay. Sub-level class method can throw any sub-level type of exception. Or suppose what you can do, you can ignore. If super level class method is specified with any checked exception, then you can ignore that exception into subclass. Means in subclass, sub-level class method can ignore the method level exception, or sub-level class method can throw the same type of exception, or sub-level class method can throw any sub-level type of exception, any sub-level. Suppose what is the sub-level of B? Sub-level of B is C. B or C. D is not there, we have not created. If you can create, that is extending C. D we creating, that is inheriting C, that also you can give, no issue. But B you can give, or C you can give. Or B you can give. You cannot give A. Because this is the violation of this third point. Sub-level class method can't throw any super level type of exception. You cannot throw. So this is super level. This is also super level. No, this is again super. That is super actually. This is the super than super. You cannot throw that at all. So my checked exception A you cannot give. You can give B only, because super level method throwing a checked exception that is named my checked exception B. So whatever the exception you can throw in the sublevel method class, that can be a my checked exception B or can be the any subtype of my checked exception B, but it cannot be the super type of my checked exception B, or you can ignore, no issue. So this is the points only. If super level class method is specified with any checked exception, then you can ignore, no issue. You can throw same, no issue, or you can throw any subtype, no issue, but you cannot throw any super type or any other. You cannot throw any other also. You cannot throw here T also. Oh sorry, yeah, you can throw any other exception also, sorry. No, you cannot throw. Should be in the subtype, sorry, in the subtype. So in the super type I have specified my checked exception B. In the subtype I have specified my I have thrown my checked exception B or C, but I cannot throw T also. Yes, I cannot throw. Sub-level class method cannot throw any super level type of exception. If it is, you cannot throw even super level type of also, then you cannot throw any other exception also. Okay. So this is all about the exception in inheritance relationship. How can you specify that? You should keep in mind. Okay, so this one is for this session only. In the next session we will see cloning. What is cloning? We have already seen in our if we see our object class, suppose if we see our object class, so in this object class one method is there, that is clone. Yes, clone method is there. So how can you clone that object? How we can clone? Is there any way that we can clone? This is a native and this is a protected also. What is the meaning of this protected? This method you can access in this class or in the same package, or you can access this method into another package with inheritance relationship only. Means into the subclass only you can access this clone method. What exactly they use? This is used to cloning the object. So we will see in the next session what exactly meaning of cloning, how we can do cloning, and why we need the cloning actually. So we will see all those topics in our next session. So till that, okay, I hope you like this session. So please subscribe my channel. Until that, bye bye, and we will see you in the next session. Thank you.